Hello friends, welcome to Planet Math. Please friends, do note that our videos now will now be in seasons and in episodes. And today we're going to start with the first season and episode 1. In episode 1, we'll learn exponent and laws of exponent. Exponent is shorthand way of saying multiply a given number a number of times as indicated in the exponent. What I actually meant by that is this. Say you are given 2 raised to the power of 3 or 2 exponent 3. What you are required to do here is to multiply 2 the number of times according to the exponent. So you have 2 times 2 times 2, and this is 8. Okay, 2 here is the base, we call it the base, while 3 is the exponent. You can call 3 the exponent, you can also call it the index or the power. Okay, one thing you mustn't do is this: don't write 2 raised to the power of 3 as equal to 2 times 3. 2 times 3 is 6, while 2 raised to the power of 3 is 8. This is wrong and this is right. So never you multiply the base by the exponent. That will make you to flip. Okay, now let's proceed. The base can be a letter, as in the case of algebra. A raised to the power of 2 is a times a. The base can be a negative whole number. This is minus 5 times minus 5, which is plus 25. Minus times minus is plus. Base can be a negative number with an odd index. Okay, this will give you minus 5 times minus 5 times minus 5. Put this in parentheses. Okay, simplifying it further, you have 25 times minus 5. All right, and this is equal to minus 125. A fraction as the base, let's say 1/4 is squared, or this is power of 2. So you have this to be 1/4 times 1/4. This is 1/16. There are cases where you have a base of this type in root form. You have 3 raised to the power of 2. This is root. This will give you root 3 times root 3, and this will give you just 3. Root 3 times root 3 is 3. You can check it out. Root 3 means 3 raised to the power of half. Okay, so root 3 square is then 3 raised to the power of half raised to the power of 2. Okay, this is 3 raised to the power of half times 3 raised to the power of half. From the we're going to consider laws of indices very soon. Okay, so for the first law of indices, which is multiplication law, we state that the bases, when the bases are the same, the powers should be added. So you have 3 raised to the power of half plus half is 1. Okay, 3 raised to the power of 1 is 3. All right, laws of exponents or indices. Alright, so you have the multiplication. Multiplication law, we are going to consider use a as a base. A raised to the power of 2 times a to the power of 3 is a raised to the power of 2 plus 3, and this is a raised to the power of 5. Okay, it could be another letter. Let's say 3 raised to the power of 2 times 3 raised to the power of 4. This is 3 raised to the power of what? 2 plus 4. 2 raised to the power of 6. Okay, a raised to the power of 2 is equal to a times a raised to the power of 3, a times a, and everything here is a raised to the power of 5. 1, 2, 3, 4, 5. Okay, the same as that. So the next law is division law. For division, when the bases are the same, the powers are subtracted. Okay, let's check it out here. A raised to the power of 2 divided by a raised to the power of 3. This is a raised to the power of 2 minus 3. Okay, a raised to the power of minus 1. Alright, so if you were having 4 to the power of 2 divided by 4 to the power of 3, this would be 4 to the power of what? Minus 1. 2 minus 3 is 1. Is that difficult? That's division law. When the bases are the same, the powers are subtracted. Okay? Okay, let's take a negative index. We're going to derive negative index from division law of indices. Okay, let's see how we go about that. Law 3, negative index, where you have 1 over a. This is something as a raised to the power of minus 1. You have 1 over a square. This is something as a raised to the power of minus 2. 1 over a, it could be any letter. 1 over x, it could be any power. This is something as x to the power of minus 3. Let's prove it. Let's prove it. Proof while using the law of division. Okay, to prove this, please permit me to wipe the board. So we are proving the negative index law. All right, let's prove the negative index law. So you have a raised to the power of 2 divided by a raised to the power of 3. Of course, this will give us a raised to the power of minus 1. Still, this same expression that gave us this, a raised to the power of 2 divided by a raised to the power of 3. This is division. This is also division. Here, this first one is giving us minus 1 because I simply subtracted 3 from 2 and I got minus 1. But here I actually want to divide out a times a, that is a square, and here you have a times a cube. Alright, so when you cancel out, there are 2 a's here, you have 1 left, so you have a 1 remains 1, and 1 times a is a, and this is the same thing as 1 over a. Now you can see that this, what gave us this is the same thing that gave us this. Of course, you know, if a, or let's use other letters, if a or if c equal d and d is equal e, it therefore implies that c is equal e. So if this expression gave us this and this gives this, it means that this and this are the same. Okay, that's a simple way of proving a negative index. For negative index, you have something like a raised to the power of 1 over 2. Here the fraction is always the numerator of the fraction is always 1. Okay, so you still have it to be a raised to the power minus 1. But there are cases where the numerator of the fraction is not 1 but other numbers. Such type of fraction, such type of expression is called fractional index. Okay, let's take that. Fractional index or exponent. Remember, another word for index is exponent. Alright, so let me wipe the board so we can take that. That's the fourth law of exponent. So we have a, we're using a as our base, raised to the power of a fraction 2 over 3. Now the fraction is having a different numerator that is not the same as the one we considered earlier. The fraction is having a denominator other than 1. Okay, so you have it 2. So this is the same thing as the third root of a, all raised to the power of 2. So if it were a raised to the power of 3 over 4, the result would be that you should take the fourth root of a and you raise your result to the power of 3. Let's consider a number so that you have 8 raised to the power of 2 over 3. This requires you, this is simply telling you to take the third root of 8 and multiply your result by 2, or raise your result to the power of 2, meaning, of course, the third root of 8 is 2. 2 raised to the power of 2 is 4. Alright, this is very, very simple, is it not? Yes, it is very simple. All you need to do here is to take the root according to the base, according to the denominator of the fraction. If the denominator of the fraction is 4, you are meant to take the fourth root of 8. Then whatever the fourth root of 8 gives to you, you raise it to the power of 2. Here in this case, the third root of 8 is 2. Now 2 is now being raised to the power of 2, which is what? 4. We have one more law to take, which is power law. Okay, when an index is raised to another index, or when a power is raised to another power, such powers are said to be in powers. Okay, so what you need to do is to multiply the powers together. Just multiply the powers and then you get your result. This is what I mean by that. Permit me to wipe the board. Of exponent. So you have x is raised to the power of 3 and all raised to the power of 2. Of course, you know this is the same thing as x 3 times x 3 2 times. Okay, remember that exponent is a way of saying that you should multiply a number of times as indicated by the power. Okay, so you know x raised to the power 3 is x times x times x. Now times this other one, s times x times x. Alright, so you have x times x times x times x 6 places, so you have it to be x raised to the power of 6. Instead of you going through this long process, it's easier and better to just write in a short way. X to the power of 2, simply multiplying the powers, you get the same result. Okay, x to the power of what? 3 times 2, which is x to the power of what? 6. time saving and space saving. One caution you must take while dealing with something like this is this: do not confuse it for addition. Okay, do not do this. X raised to the power of 3 all squared is not equal to x raised to the power of 3 plus, you can say it, plus 3 plus 2, and of course this is giving you x to the power of 5. This is a very wrong approach, a very wrong result. Thank you very much for watching our videos. Please do consider to subscribe, like our videos, and share them. Next time we'll be having episode 2 on season 1.